In this video, we are going to work through the following example. It says use a power reducing formula to rewrite the expression with an exponent no higher than 1. All right, and so the expression that we have is cosine squared times sine to the fourth of x. So looking at the power reduction formulas, I can see that I have power reduction formulas for sine squared, cosine squared, and tan squared, but not for the fourth, right? So what you want to do when it has the fourth power like that is to rewrite it as a power of sine squared. So in other words, write it like this. And right, in other words, sine to the fourth power is sine squared squared, right? If I take sine squared and I multiply it by itself, I get sine to the fourth. And of course, sine squared squared is just shorthand notation for sine squared x times sine squared x, like this, okay? And now I have power reducing formulas for each of these three things right here. Okay, so the first one, cosine squared x, that's going to be 1/2 1 plus cosine of 2 times what's in here. Okay, so that's 2x. All right, and next up, sine squared. If you look at the power reduction formula for that, it's going to be 1/2 1 minus cosine of twice what's in here, which is x, and so it's going to be 1 minus cosine of 2x. And then same thing here. Okay, and so now I'm going to need to multiply all this out. Again, you might say, hey, well, all of these are just to the first power, but the Newton problems are not going to have answers that look like this. They're going to be multiplied out into some form or the other, okay? And the reason for that is because that's the form, whenever you're doing this, the form that you generally need is to have it multiplied all out. So that's why they do that. All right, so all of this is multiplication here. So I have these three factors, and so I'm going to go ahead and multiply the halves together. 1/2 times 1/2 times 1/2. That will come out to be 1/8 when I do that, okay? And then what I'm going to do is start multiplying these factors out. 1 plus cosine 2x, 1 minus cosine 2x, 1 minus cosine 2x. And in particular, what I'm going to do is multiply these two first as opposed to multiplying these two out, okay? The reason for that, it's just a little easier that way, in my opinion. If you look, right, these actually is multiplying 1 plus cosine 2x and 1 minus cosine 2x is actually going to give a simpler result than multiplying out these two, at least at first, okay? We're going to see it's going to expand back out again. So, okay, I'm going to go ahead and multiply 1 plus cosine 2x times 1 minus cosine 2x. I'm going to use the FOIL method to do that. It's first, outer, inner, last, right? First times first is 1. Outer is minus cosine 2x. Inner times inner is plus cosine 2x. And last times last is minus cosine squared 2x. And don't forget, I would still have this 1 minus cosine 2x out here. All right, and so if you look inside that first set of parentheses, you're going to see that there are some like terms, and so they can be canceled out. Minus cosine 2x are combined, and they cancel out in this case because they have opposite coefficients, right? Minus cosine 2x plus cosine 2x. So inside that first set of parentheses, I'm just left with 1 minus cosine squared 2x. Okay, so now I would need to multiply these out, right? The issue that I'm going to have here is that I already have a cosine squared inside here again, okay? So what I'm going to do is I'm going to go ahead and get rid of that cosine squared using the reduction formula again. All right, and so I'm applying the reduction formula for cosine. So that's going to be 1/2, 1 plus cosine of double this angle, right? So that's going to be 4x in that case. Okay, and then I am going to simplify. Inside the parentheses, I have 1 minus 1/2, and I'm going to distribute that negative 1/2 through the parentheses here and here. So I get negative 1/2 minus 1/2 cosine of 4x. Okay. Then I have some like terms here, right? 1 minus 1/2 is 1/2, so I have 1/2 minus 1/2 cosine 4x. Times 1 minus cosine 2x. Like so. Okay, so again, the Newton answers probably are not going to have an answer like this. It's going to be multiplied out, right? So I'm going to go ahead and FOIL out these two expressions here. All right, so first times first, it would be 1/2 times 1, which is 1/2. Outer would be 1/2 times minus cosine 2x. So minus 1/2 cosine 2x. Inner would be minus 1/2 cosine 4x times 1. So that's minus 1/2 cosine 4x. And then last times last would be minus 1/2 cosine 4x times minus cosine 2x. So that's going to come out to be plus 1/2 cosine 2x times cosine 4x. Like so. All right, there are no like terms to combine here, right? 1/2 is not like any of these other terms, right? Cosine 2x is not like this because the numbers inside the cosine are different, so they can't be combined together. And then cosine 2x, cosine 4x, I have both of those, so they can't be combined with this because it's missing the cosine 2x. This term is missing the cosine 4x. This term is missing both cosines. So I can't do any combining on the inside. The only thing I can do is to distribute this 1/8 through the parentheses, and I guess we can go ahead and do that. But I'll have to erase the top two lines. To do that, to make a little room. All right, and then when I distribute that 1/8 through the parentheses down here, 1/8 times 1/2 is 1/16. Then it's going to be minus 1/16 cosine 2x. minus 1/16 cosine 4x plus 1/16 cosine 2x cosine 4x. All right, and that is it for this example.